was figuring out areas under curves. Okay? So hopefully you can see if it's not a nice shape, I'll show you if it's like a rectangle, things like that, you can just literally do length times width and get the area. But not all curves are simple rectangles or triangles or simple shapes. So we break the curve into shapes that we know. In this case, we're using a rectangle. Hopefully you can see that if I added the areas of all these rectangles together, I'd get an approximation of the curve, right? That would be of the area under the curve, but it would be an underestimate. Triangles probably wouldn't be the best, but you theoretically could. All right. And then on the one on the right here, you can see if I added up all those areas, I'm going to get a bit of an overestimation. Okay. So this one is, I'm going to call this, I'll just say it's an underestimate. Can't spell estimate. Estimate. Underestimate and an overestimate. There we go. Okay. Now, if we just start thinking about this mathematically, the area is going to be the sum of all the rectangles, right? Right? Okay. I'm not going to write the word sum. What am I going to write to represent a summation in math? Sigma. You're close. That's the next step. So it's going to be the sigma of what's the area of a triangle or of a rectangle? Or the width times the height. That's what I'm going to call it. Okay.
I don't know what I'm saying.
So the height of the rectangle times the width of the rectangle gives you the height. All right. If you look at the first one here. Oh, go away. This underestimation. I'm going to use the symbol I to represent the rectangle. I is equal to 1, I is equal to 2. I represents the rectangles. Which rectangle you're in. Okay. This one, we're going to use our height is going to be that point right there because that's hitting the curve. So I call this right endpoint. And this one over here is going to be left endpoint because we're using the left side of the rectangle. And this height right here is going to be your A value, which is your furthest point here to the left, plus the rectangle number, which we're calling I, times the width of the rectangle. So I'll explain that here. So it looks a little weird. I'm going to call that. I'm going to call this point C. Okay. Therefore, C is equal to A plus I delta X. So what that means is if I want to know the height of a certain rectangle, and say it's rectangle 3, okay, I'm going to take the A value, and then I'm going to add 3 rectangle number times the width, because it's 3 rectangles. So that's the height I want. Okay, does that make sense? If I want to know the height at this point here, this value right here is this number plus the width of the rectangle, which we're calling delta x, times how many rectangles, which is, that's just say 3, not 2. 3. All right. So if each rectangle has a width of, I don't know, say 2 centimeters. All right. They're all the same width. And I want to know this point right here. That's going to be, and we'll call A 0. Okay. That's going to be 0 plus 3 times 2, which is 6. So this point right here is 6. Okay? Does that make sense? I'm just making it 0. It could be anything. I'm just calling it 0. And just for this example, I want to know what this point is here. All right? But if each rectangle has a width of 2 centimeters, that's 2, 4, 6 centimeters over. Yes? Okay. This is the formula when you're using right endpoint. Okay? The formula for left endpoint, this one right here, is going to be the a value plus I minus 1 delta x. Why is it I minus 1? Yeah, because if you're using the first rectangle, right? If I'm using the first rectangle, I want this point here. So I put 1 into this formula. 1 minus 1 is 0. That wipes out. So then our C value is just the A value. Okay? You just need to remember these two formulas for right endpoint and left endpoint. Okay? That's the reason they are. And that's essentially, this formula gives you C is the height. Or actually, F of C, check that, don't erase that. F of C is the height. So let's, hang on. Erase, don't say height. Don't call it the height. You'll see I'm going to change it in a sec. Okay, so now we go back to our formula. Area is equal to the sum of the height times the width. The sum of all the rectangle widths. Okay? Starting with I is equal to 1, because that's our first rectangle, to n, whatever number of rectangles we're going to add. Okay? The height of each rectangle is dependent upon whether you're doing this one or this one. And it's going to be this C value. Okay? Because if it's this point here, I put 6 into the whatever function it is, and that spits out the y value, the height of the rectangle. Okay? So it's going to be F of C. So this is going to be the sum, I is equal to 1 to n of F of C. And then the width, what's the width of each rectangle? Well, okay, yes, but in a general sense, what is it? Delta x, all right? Sorry. You're right, it is 2 in that particular case, but in a general sense, it's delta x. Okay. This is essentially the formula we're going to use to figure out area, to give a range of areas. We're going to add something else to it when we want the actual area. All right. Let's do, and so depending on whether you use left endpoint or right endpoint, either one, your C value is going to be slightly different. Okay, and we'll look at that in a sec. Your delta x, there is a formula for delta x. Delta x. Can anybody tell me how to get the width of the rectangles? That's what delta x represents. So think, if I gave you this, if I said, here's a function, I'll just do this one right here. And this was 0, and this is, we'll make it easy, 10. And I do 1, 2, 3, 4. How do you get the width of each rectangle?
The axial intercept.
So you go the difference between these 2 points, right? 10 minus 0, or b minus a divided by the number of rectangles. So delta x is b minus a over n, because n is the number of rectangles. All right, and then I'll just write it because it's all, we can keep it in one spot. C is equal to a plus I delta x. This is right endpoint. And C is equal to A plus I minus 1 delta x. And that's left endpoint. Okay, with all this, we can now give an estimation of areas under curves. All right. That's the theory behind it. I'm not going to ask you to reproduce that. What I'm going to ask you to do is what we're about to do. Actually, a version of what we're about to do. So, see, this is what we're doing. See? That's what we're going to do. That's why we needed to rest stuff. Okay. So, find the upper and lower approximations We're focused. I'm recording. Hang on, I can stop it. Okay. All right, I always draw a picture. You don't have to draw a picture. I'm going to draw a picture. So find the upper and lower approximations of the area under the curve y is equal to negative x squared plus 5 between 0 and 2. All right. So we're talking about this. X squared minus 5 is a parabola. I'm just going to call this. Why did I say 5? All right, 5, whatever. That's going to be root 5. But I just care about to 2. So that's the area I want. Okay? Like this is what I'm trying to figure out, this area. Okay? Between 0 and 2. And we're using 5 rectangles. You don't have to draw all the rectangles, but sometimes it helps. So I'll do the right endpoint one. 1, 2, 3, 4, 5. All right. Yeah. Doesn't matter. I know that the x-intercept for this function is going to be root 5. All right. Because, right, like if you said 0 is equal to negative x squared plus 5, I'd get x squared is equal to 5. So x is equal to plus minus root 5. I know the x-intercept will be root 5. 2 is just less than it. I don't really care where it is. It doesn't actually matter. The drawing doesn't matter in terms of like you want to be similar to what it looks like, but it helps just with the visual eye fun. Okay?
Why is it 5? It's always like that. Like, is it 5? Because it's plus 5, right?
Yeah.
5.
Why is that 5, you mean?
No, like, if there is no there is no plus a number, how do you know how many
Oh, I see. Didn't I write that? Oh, it's because I didn't write it. I think I just said it. Using 5 rectangles. There you go. I have to tell you the number of rectangles. Okay? Sorry, that's a very good question because I didn't write that. I said it in my head, but I forgot to write it down. Okay, so yes, we are using 5 rectangles. I will tell you the number of rectangles. Okay. All right. Okay, so we're going to do right endpoint and then we'll do left endpoint. So, because you need an upper and a lower. Okay. So let's figure out we know that the formula is going to be I is equal to 1 to 5, because we have 5 rectangles, f of c delta x. Right? That's the formula from right there. This formula right here. Okay. Delta x is going to be b minus a over n. B is 2, a is 0, n is 5, so it's 2/5. It's delta x. Each rectangle has a width of 2/5 or 0.4. Sorry?
Will we label that on the?
No. We're not going to label it. We're just going to put it into the formula here in a sec. Okay. And then C. What's C if we're doing right endpoint? So this is going to be right endpoint. What's the C value? Yeah, it's a plus I delta x, right? Okay. What's our A value?
0.
Yeah, this is A, and this is B. So C is going to be 0 plus I. Delta x, we just solved that, is 2/5, or 0.4. Do we want to do the decimal? Let's do the decimal. Okay. So I'm going to write 0.4i, just to be 0.4i. There we go. Okay. All right. So now you plug it into the formula. So it's the sum from I is equal to 1 to 5. F of C, our C is 0.4i. And delta x is 0.4. All right, are we okay? Everybody? Okay. Now, what's our function? Negative x squared plus 5. So that means we have to put 0.4i in for x, right? Because whatever's, it's like functional notation, whatever's in brackets, we sub in for x. So we get the sum of I is equal to 1 to 5 of 0.4 I squared negative plus 5. Now this is where you got to be careful with your brackets. You have to bracket that, okay? And then the 0.4 sits on the outside. Okay, so this is that. Because I can't have f here, right? I know what the function is. Say this is like f of 2. It has a value, right? It's the height, okay? Are we okay? All right. So now we're going to do this. So we go, the sum of I is equal to 1 to 5 of 0.4. What's 0.4 squared? 0.16. And then we square the I. The negative's on the outside, so we're going to get negative 0.16 I squared plus 5. And we're multiplying that by 0.4. We okay? All right. Now we dump this in. I need a calculator. What's 0.16? 0.16 times 0.4 is 0.064 negative 0.064 I squared plus 0.4 times 5 is 2. Are you with me? Yeah? Okay. I'm going to break this up because we're adding to two different summations. That's a bad summation on the second one there. All right, you can pull constants out, right? So I'm going to pull the negative 0.064 out. So now what do we do?
Formulas.
Yeah, we've got it down to the formula. What's the sum of I squared? Yeah, it's n, so 0.064. It's n times n plus 1 times 2n plus 1 over 6, right? Plus the summation of 2 is just, of a constant, is just nc, right? And then you just put in your n value, which is 5. Did we get that? Yeah? Okay. Now we gotta do left endpoint. All right, I need to show you the left endpoint. I won't ask you to do both of them, so don't worry about that. All right. So this is what it looks like at the end. There's our one question. Okay? That's right endpoint. Now we're gonna do left endpoint. And you're gonna see why I prefer using right endpoint. It doesn't matter, you can choose either one when we do the actual question, like where we get the specific answer, but I need to show you left endpoint just because. All right, so we go back to the top. It's the exact same question. So now when we do it, we're gonna do the overestimate. So you don't have to draw this graph if you don't want to. I say that's 2. We're using the left endpoint, so our triangles look like this. Or rectangle. I keep saying triangles. I'm going to move the 2. 1, 2, 3, 4. There's 2. 0. Okay, so you can see we're going to get an overestimate. Our delta x is the same. Does everybody agree with that? Delta x is going to be the exact same. The c value is what changes. C value for left endpoint, so this is left. Is c is equal to a plus I minus 1 delta x. A value is 0, so it's I minus 1 times delta x, which is 0.4. So we can call it 0.4 I, minus 0.4. Okay, there's a C value. We're good? Okay, now everything's the same. It's going to be the same algebra. There's going to be it'll be a little trickier with this one just because of our C value. But essentially what we're doing is we're going, okay, we're summing all the rectangles from I is equal to 1 to 5 with heights f of C times their widths delta x. Our C value we just said was 0.4I minus 0.4. So that's going to be the sum. Half of it is just writing the sum formula. And delta x we said was 0.4. Okay. Okay, wait with me? All right. Okay, I'm just going to do this off to the side because it's going to be kind of messy. Remember, whatever's in brackets here goes where? Goes in for our function, right? So if we take that, our function is negative x squared plus 5. So if I have to put that in, I'm going to get negative bracket 0.4I minus 0.4. Yeah. Okay. And it's squared plus 5. So why is this not fun? Why is this method, you can probably already see why this method isn't as much fun. Not that the other one was fun, but you're going to have to expand this. This is the binomial, right? So it's 0.4I minus 0.4 times 0.4I minus 0.4. So that's the fun we're going to do right now. All right, here we go. I prefer right.
Can you just pull 4 off right now?
Yeah, we can do that. You want to do that?
Yeah.
Okay, let's do that. Negative 0.4 I minus 1 squared. Does everybody agree with that?
I mean, that,
Hmm?
No, like I think he means can we pull out 0.4 and then like plug the whole thing. No, that's very nice.
What?
Well, that's one for in front of the sigma. Yeah.
No, not like
This one you can,
those two.
but you can't do this one because it's inside the function, right? Are you talking about this 0.4?
Yeah.
Yeah, you can, but that's not. We're not doing anything with that right now. We're just doing this right now. Yeah, but yeah, we can pull that out later when we start to do that. But we have to deal with this first. Okay. Does everybody understand what I did here? Okay, let's go back to that one then. Just go back to the other one. Okay, let's FOIL this. I'm going to do it old school, people. Plus 5. So, not squared. Oh, sorry. The heat's getting to me too. Okay, there we go. All right. Now we have to FOIL this. 0.4I times 0.4I. What's 0.4 times 0.4? There you go. 0.4I times that is 0.16. Negative 0.16. I minus 0.16. I plus 0.16. We can do it with fractions if you want. Minus 0.32i plus 0.16 plus 5. Then what do you do with the negative?
You can factor the 0.16.
You can factor 0.16 out. I'm just going to keep it. You can't. Go for it. I'm just going to do this. Go away. What's 5 minus? That's, there we go. It's 5 minus that. 4.84. 8 what? 8.4, right? Yeah.
So you're probably gonna give this one a test.
No, I'll show you what I'll give you on tests.
Are we ever gonna be forced to do the?
No, you're not going to be forced to do the left and right endpoints. Like, I won't ask you to do both. And left endpoint, I never do left endpoint. If you have a choice, you don't. You'll see at the end. I'm doing this for a reason. This is what they used to have to do. Okay? You will have to do something, but it won't be like this. And I'll give you nice numbers and functions. Okay? Oh, no. You'll see. It's okay. So there's our function. That goes right there. So this is going to look gross. Here, I'm just going to move it down here because I need the space. Here we go. The sum, I is equal to 1 to 5 of this gong show, negative 0.16. It'll clean up. Don't worry. Maybe 0.4. Okay. Are we ready? Okay, sorry. Pick like the hottest day of the year to do this too.
Hottest day of the year.
Was yesterday hotter?
Probably.
I think Friday was the.
Yeah, Friday was like.
Okay, the third hottest day of the year. All right. Okay, I can pull constants out of sigmas, right? Okay, so let's pull a 0.4 out. And I need to break up all those other ones, okay? So I'm pulling this 0.4 out. And then I'm splitting up all the other ones. It actually looks better when you do it with fractions, I would argue. But that's okay. Because mine I did in fractions. I think it looks cleaner. No?
No.
Okay, so now we've got it to the point that we can use our formulas. Does everybody agree with that?
Yeah.
Because we have an I squared. So I'm just going to turn this into, so the 0.4 is multiplied by everything. The negative 1.16 comes out. The sum of I squared is n plus 1, 2n plus 1 over 6. Sum of I is n plus 1 over 2. Oh, I forgot the 0.32 on the outside. And then the constant is just 5 n times c. So 4.84 times 5. And we know n is 5 for all those ones, so it's going to be 0.4. This is going to test your calculator skills here. 5 times 6 plus 11 over 6 plus 0.32. 5 times 6 over 2 plus whatever this is, 4.84 times 5. All right. Punch that into your calculator. I wouldn't do it all at once. I'd do it in bits. Well, that's 15, not 30. $8.08.
Sure.
That's what I got, and that matches my notes too.
Yeah, well, that's-
You're just gonna go with it. Seems right. Okay, so what does that mean, people?
I thought we were done.
No, this is one last thing. We're done all the yucky math. It means that what was the other one? The other one is 6.48. That one's 8.08. Therefore, our area is less than 8.08, but greater than 6.48.
All of that to go range.
All of that to get a range. Exactly. So my question to you is, this is the accumulation of the last hour or 40 minutes or however long it took us. How would you actually get the exact answer?
Divided by 2.
No.
Oh, into the infinity. Into it. Oh.
No.
If you make the rectangle smaller and smaller, because if you make the rectangle smaller, you're going to get a better approximation, right? So you make delta x really, really small, and you make an infinite number of rectangles in there, you will get the exact answer. That's what we're going to do tomorrow's class. It's going to be the summation as the limit as n goes to infinity of this. It looks like a gong show. It actually is easier than all the stuff we just did because you don't have to do both sides. You just pick one side. And as we demonstrated, which is the easier side?
Right.
The right side. Correct.
Amazing.
No homework.
Amazing.
Right.
No homework.